Hello everyone, welcome to the miscellaneous part, miscellaneous questions of complex analysis. We are taking here some miscellaneous questions of complex analysis. Question is that given fz equals to sine hyperbolic z upon z raised to the power 5, find the residue of fz at z equals to 0. यहाँ पर फंक्शन गिवन है हाइपरबोलिक साइन हाइपरबोलिक z अपॉन z रेज टू द पावर 5. We want to obtain residue of this function at the point z equals to 0, or we can another way of the question is that function of z is given here and find the residue of this function at its pole. So basically we are using expansion, series expansion. So this is the Taylor series expansion, or generally expansion of sine series. This is sine hyperbolic z equals to z plus z cube upon factorial 3 plus z5 upon factorial 5 and etc. So we want to obtain the residue of fz at z equals to 0. Simplification gives us this one. जैसे कि यहाँ पर 1/z5 करेंगे तो 1/z4 एंड एटसेट्रा ये रह जाएगा. तो रेजिड्यू ऑफ fz at z equals to 0, दिस इज द कोफिशिएंट ऑफ 1/z, क्योंकि इसमें कोफिशिएंट ऑफ 1/z अवेलेबल नहीं है, देयरफॉर उसका कोफिशिएंट 0 है. सो वी कैन से रेजिड्यू ऑफ fz at z equals to 0 is the coefficient of 1/z, that is 0 here. So answer is 0. Next question, this is the practice question. Find the residue of fz function of z equals to sine z upon z raised to the power 2n plus 1 at the point z equals to 0. Similar way, we will obtain residue of this function at z equals to 0. Answer is 0. Basically, sine series expansion of sine z in terms of z is given by in this series. This is infinite series and nth term is given by this one. So on expanding this one, z1 is z cube upon factorial 3 plus z5 upon factorial 5 and etc. So generally this series can be written in this way. So sine series is n equals to 0 to infinity minus 1 to the power n z raised to the power 2n plus 1 upon factorial 2n plus 1. Now we are observing that here is at again no coefficient of 1/z. So residue of this function at z equals to 0. You can expand and solve easily, and you will obtain the answer or solution of this question. So we are working here miscellaneous part, miscellaneous questions of complex analysis. Next question we have. This is the next question. Let us take function of z. Function complex plane to complex plane be an entire function. This is given that plane is whole C. So this is an entire function, and function limit at z equals to 0, function of 1/z is infinity. Then function f can have at most finitely many zeros. So this is the basic definition of pole. If function is entire, that means analytic in whole complex. So fz fc to c, and given limit z tends to 0, f1 upon z equals to infinity. f1 upon z tends to infinity का मतलब है f1 upon z has pole at z equals to 0, or fz has pole at z equals to infinity. अगर f 1/z इस पर तो fz infinity पर. So entire function having pole at infinity must be polynomial. entire function के लिए अगर entire function है polynomial, trigonometric function etc., these are entire functions, or entire functions having pole at infinity, that will be a polynomial. And polynomial can have at most finitely many zeros. So this statement is, we can say, true. Then f can have at most finitely many zeros. Polynomial can have at most finitely many zeros. So we can say this is true statement, or this question is true, or you can find, if there are so many options, then you can check or solve easily. So thanks for watching.